All right, so solving inequalities, you should hopefully be pretty comfortable with graphing inequalities that we talked about yesterday. But today we'll cover solving inequalities. Again, just a reminder that this is less than. Another phrase that means less than is fewer than. This inequality symbol right here is greater than. A couple phrases that mean greater than, more than, or exceeds. Right here we've got less than or equal to. It could be no more than, could be at most. This one is greater than or equal to, no less than, or at least. I always struggle with the greater than or equal to and the less than or equal to with these two ideas and the other meanings that they have. So those would definitely be good things to write down in your notes, is that less than or equal to means no more than or at most, and then greater than or equal to means no less than or at least. The equal sign with the slash through it just means does not equal. I think you saw an example of that on your worksheet for today. So does not equal, equal sign with a slash through it. And here's one of the most important things to take away from today, is that solving inequalities is really nearly the exact same way that we solved equations, really doing the exact same ideas and the exact same things. So your mindset should be pretty good after having come and solved all those different equations. It should be in a good frame and a good place to solve the inequalities today. So we'll start with some translation. So we've got the words and we need to go to the numbers and the symbols. So I get my pen pulled up here. All right, so your age is less than 6 years. Okay, so maybe I just let my variable be A for age. Sorry, I gotta get my pen back up. Okay, so age less than, I know what that looks like. And then 6, right? Age is less than 6 years. Not too bad there. This one, your height is at least 60 inches. So maybe that's a case where you go back to your notes, you look at this phrase at least, you see that it's a greater than or equal to, and you can apply it to this problem. So your height, maybe we let age be our variable. Again, at least greater than or equal to, so greater than or equal to 60 inches. So it's at least 60 inches, right? 60 inches is kind of the minimum. It could be anything bigger than 60 inches. That's why we choose the greater than or equal to. Anytime that you need to pause this video and like write stuff in to better your understanding, to help your notes, definitely take advantage of that. So if I'm moving too fast and you can't keep up, just pause it, resume it whenever you're ready to jump back in with me. All right, so we get to solving. Again, treat these just like equations. So draw your line right through the inequality, your both sides line. And then you can start doing things to both sides. So it looks like we've got just kind of a two-step inequality here. So I want to move things away from my variable. So let me add 5 to both sides. And by doing that, my 5's cancel on the left side. I've got my 2x left over. That equals, be good with integers, negative 11 plus 5 is a negative 6. So divide by 2, and I've got that x equals negative 3. Oh, excuse me, not even equals. So let me back up here. All of these equal signs in the solving equations mindset, these should all just be greater than signs. So that's my bad. So all those are greater thans, all right? So again, it's so similar to equations. I made a mistake there and threw an equal sign in, but we should have greater thans all the way through. So when I come over here to graph, I'll make sure I put negative 3 in the middle. Got to be good with the negative, so negative 2 would go to the right of that, and negative 4 would go to the left. So because it's a greater than, that's an open circle on negative 3. And it's in that good form where it's the variable, then the inequality symbol, then the number. So I can shade the way that my inequality points. So that's to the right. So I'll do a bunch of squigglies out to the right. All right, let's go to the next example. Again, looks like another two-step equation. So I'm in the mindset I want to get everything away from my variable. So I should subtract 100. Subtract 100. All right, so let me get my line drawn here. So over on the left side now I have negative 100. That's greater than or equal to 5x. I'll divide by 5, divide by 5. I get negative 20 on the right, excuse me, on the left side. I've got my greater than or equal to, and then 5's cancel, so x on the left, excuse me, on the right side. Gosh, I can't talk. All right, so again, this is not in that good form where it's the variable, then the inequality, then the number. It's switched around. So that's going to mess us up when we try to shade it if we would try to shade it this way. So the better way to write this would be to take this and move it to x on the left side. My inequality points towards x, it opens towards -20, so I want to make sure it does all those things. Points towards x, and it opens towards -20. So that's how I'm going to rewrite my new inequality, my new final statement. So -20 in the middle. Again, negative, so -19 could be to the right, and -21 could be over on the left. This time I've got a closed circle because it's an or equal to, and then I want to shade the way that it points because I moved it to this good form, so I would shade to the left, the same way the inequality points. Again, can't stress enough, if it looks like this, make sure that you get it moved to that form. That way you can use, okay, it points left, I need to shade to the left. It's a great trick, but you've got to make sure you're in the right form to use it. This is an extremely important rule, so please, please, please write this down in your notes. Make it a point to remember this. This is probably the one big difference between solving an equation and solving an inequality, is that if you multiply or divide by a negative, you've got to flip the direction of the inequality symbol every single time. So whatever you have to do to get that through your head, write it down, say it over and over again, but this is an extremely important rule to remember. It's something you have to do every single time that you multiply or divide by a negative in an inequality problem. Okay, so I'm solving this one. I'm going to draw my BS line in right through the inequality, right through my greater than. I want to get the variable by itself, so I should add 1, cancels out my 1s. Make sure you get the sign on that negative 13x, bring that down. I've got my greater than, and then I've got -39 over on the right side from doing -40 plus 1. Again, be good with integers. Well, I need to get x by itself, so I should divide by -13 since they multiplied by a -13. Make sure I do it on both sides. And here's what I've got, right? I just divided by a negative, so if I reference this line right up above here, dividing by a negative means that I need to switch the direction of my inequality symbol. So my -13's cancel on the left side. I've got that x. Switch my inequality symbol from greater than to less than. And then I've got, looks like a negative divided by a negative, which is a +3. So look at that change, right? We've got greater than right here, but then when we divide by that negative, now it gets switched to a less than. That's going to happen every single time that you multiply or divide by a negative. You've got to switch that inequality symbol. Get it in your head. 3 goes in the middle, 4 to the right, 2 to the left. Again, working with positive, so just your typical 2, 3, 4. This time it's a less than, so open on 3. And I'm going to shade everything to the left of that because it's in my good form where it's the variable, and it's the inequality, and it's a number. So I can use that it points left, I shade left. Multiply, divide by negative, got to flip it around every single time. Don't forget to do that. All right, here's another one. So I want to get the variable piece by itself. That's right here. BS line, -12, -12. I've got 52 minus 12, which is 40. I've got a greater than or equal to, and then a -5x on the right side. So I want to get x by itself. Let me divide by -5 to do that. Do it to both sides. And now I've got -8, but I divided by a negative to get there. So that means I need to switch my inequality around to a less than or equal to. And then my -5's cancel, and I've got x on the right side. This isn't in that good format, so if you went to try to shade it like this, you're going to shade the complete opposite direction as what you need to. So move it to x on the left side, opens up towards x, points towards -8, so opens up towards x, points towards -8. There's that good flip version where it's in the standard form where it's your variable, your inequality, your number. Can't stress getting to that enough on every single problem. -8 in the middle, -7 to the left of that, excuse me, to the right of that, -9 to the left of -8. This time it's an or equal to, so I would be shaded on -8. Points to the right, it's in that good form, so I can shade over to the right. All right, let's see. Just some key reminders. We've graphed. We did that kind of in a separate day. We did that yesterday. So just a reminder that open circle for less than or greater than, and then you can shade whatever direction your arrow points. And then it's a closed circle for less than or equal to, greater than or equal to. And we've already graphed this. So there's no need for you to go back and do that. This is an idea that maybe you had a question on. It's from the assignment that hopefully you have done with you over the kangaroo. But if x is not equal to 3, that's our key point is 3. So we'll do 2 on the left, 4 on the right. If it's not equal to 3, that means I can't include 3, so that would be an open circle. And then everything else but that 3 would be shaded in. So that's what it looks like, just open on that thing that it can't equal. Everything else works out. Everything else is shaded in. I want to add in one more for you just because this is always a thing that kids make mistakes with. Let's say I get to this. Let's say I've got, gosh, let me think of a problem here. 2x plus 2 is greater than or equal to negative 12, okay? So I'm going through, I'm solving this BS line, need to get this piece by itself, so I would subtract 2, those go away. I've got 2x on the left side, greater than or equal to negative 14 over here. Now I divide by 2, okay, on both sides. I'm going to say that again. I divided by 2, positive 2, right? Not negative 2. So I didn't divide by a negative. There's no reason for me to switch my inequality around. These 2's go away. I've got x is greater than or equal to negative 7. The confusion is from this piece right here. Kids always want to say, well, I divided a negative. That's fine. You can divide a negative. You just can't multiply or divide by a negative without switching your inequality around. So if I was to divide by negative 2, then yes, I need to switch it. But since I divided by a positive 2, completely fine. No need for me to switch my inequality, even though the number I'm dividing is negative 14. So that's kind of a tricky idea. Maybe that's something we can go over when I get back on Thursday. But I hope these notes helped. Use them, understand them, interact with them. When you get done with this, your assignment is to do the mattress maker side of the worksheet that you currently have. So you did the kangaroo side, just flip it over and do the mattress maker side, and we'll check both on Thursday. Let me know if you need anything. Best of luck. Have a great day.